Hello everyone and welcome back to the Svelte D3 YouTube series of little videos where I explain how to build data visualizations with D3 and Svelte. And let's right switch into the code editor and our test browser. Let me just switch over and we see the project we did last time, basically animating 1,000 circles with different random colors to random positions on our screen, fully responsive using the full screen width and height which is available. And yeah, we did it with 1,000 circles, and it's basically built with an SVG. So you can see that here it's an SVG where we loop over the data which contains the data for the 1,000 circles, and that works quite nicely. We have here the circle component which takes an X and Y radius and a fill, and we calculate that by scale functions that we took from D3 basically, and they are defined here above. And here is a little function which is setting our data every 2000 milliseconds. Every 2 seconds we calculate a new data set of 1,000 circles. And well, the thing is that it has one problem. Our little code here, it works nice with 1,000 circles, but if I change it to 10,000 circles like that, then we'll get the 10,000 circles, but the animation isn't smooth anymore. So there is now a little bit of a problem with our browser because it has to recalculate the positions and colors of 10,000 HTML or SVG nodes here, the circle nodes, every time. And that's quite a problem. So let's look into our circle component. Yeah, it's just writing here this SVG circle component. And that's not very efficient because the browser has to recalculate like all the stuff during the animation for all these 10,000 components. And it gets even worse if we add, I don't know, 50,000 circles. I have no idea what's happening now. It works probably. It takes quite some time, and now our animation is working. Oh, you don't see anything. Well, let's go back to the 10,000 circles where we already have the problems. And oh, okay. This is what's happening when you have a German Chrome browser and everything is crashing because there are too many nodes. So let's restart that with 10,000 circles. And let's find a solution how to code that, because you might have data visualizations with a lot of dots or whatever entities, or this is just circles. You might have per circle a number of SVG elements that you combine, and you want to animate those, or you want to efficiently draw to a mobile screen or whatever, then you need something else. And what we need there is, tada, the Canvas API. Let's see in the MDN docs what the Canvas API basically is. So, well, the name is already the program here. So we have just one HTML element, which is the canvas, and that's the canvas where we want to draw on. And we can now use JavaScript to draw dots or whatever we like. So they have an example here where they draw a green rectangle, and you can see that you need like this canvas variable here that you get from the canvas. This is basically your canvas HTML element. And then from that, you have to invoke the method getContext with the argument 2D, and then you get the context. That's a little bit like your pen with which you can draw on the canvas. And then you have to, with a very imperative API, you have to say ctx.fillStyle, set the color to green, and then you can draw a rectangle, and there's also functions to draw circles, lines, paths, whatever. And it's quite cumbersome to work with the Canvas API because it's an imperative API. It's like the D3 API as well, so you have to tell everything and you do not see immediately what's happening. And well, you need these 4 lines of code to just draw a green rectangle. Now imagine we have to draw 10,000 circles or even more. We would need a lot of lines of code and a lot of imperative code, JavaScript, spaghetti code. And that's not what we want. So let's go back to our code editor and find a solution how we can use the functionality of Svelte to make working with the Canvas API a little bit easier. So basically, let's go to our HTML code. So you can see that here for the SVG, basically, that's our canvas in the SVG world. So it would be nice if you could just say something like that. So let's use a canvas Svelte component that we open here. And then let's put like the circle in there. And of course, if I store that, everything breaks because there is no canvas component. And usually, if we have a look into the API, it's not possible that the canvas HTML element can have children. It looks like that, but it's not possible. We have to draw with JavaScript on the canvas. There's no HTML or whatever possible. So how can we build that like that we use a canvas Svelte component and put in like the circles as children here? Well, we have to redefine, so we have to define this canvas component. So let's just create a new file first where we say, hey, this is canvas.svelte. So we have now the canvas component, which is an empty file, and we can also import it here, import canvas from canvas.svelte. That looks nice. Now there's not much errors, and now it says, okay, with height are properties that we have not defined yet. And I mean, you remember that we can define properties with the export keyword, export let width, and export let height. And basically what we also need is in the HTML part our canvas element, so we can write it like that, for example. Now we have a canvas element, and I guess if we look here into the HTML of our app, let's make that a little bit bigger for you. Oops, that's okay. Then we can see here's main, and here's our canvas element. But well, there's nothing rendered, and you can also see the canvas is 300 by 150 pixels large. So this is like the standard size. We want the size of our window, of course, and we know it because we have width and height. It is not that easy. We cannot just say canvas width is now our width that we get from the property from outside. No, that's unfortunately not possible. We have to scale and adjust the size of our canvas with JavaScript. And now let's do something like that. So we do a bind this, which is a Svelte directive, and we bind a JavaScript variable now to this canvas HTML element, and we define that one here on top. So now basically if I go back to here the MDN web docs, you remember that line of code here. So let's grab the canvas from our document. That's exactly what we're doing here with this let canvas, and bind this directive from Svelte. So now we have access in the JavaScript world to this HTML canvas element. Let's store that because that's nice. And now basically we can scale the whole thing. Now there's one thing to remember with canvas now. Nowadays you have a lot of screens that have a device pixel ratio greater than 1. That means, for example, if you have a retina screen or you have a screen with a very high resolution, it has basically more pixels than you could draw in the memory space. So that means we have to scale our canvas depending on the device pixel ratio that we have. And for that, basically, I have a function that you then can also just draw from this repository, where you can find a link in the description here. So I bring that in. It's a function which is just called scale canvas, and this scale canvas function is basically just taking the canvas, the context, so we don't have that yet, the width and the height, we know that. So basically we need the context now, and the context basically we can get it from this canvas here, but we have to wait until our component is mounted, until this HTML element canvas is created. So what we do is we use now a little Svelte lifecycle function, which is called onMount. We import that from Svelte. And we can call this onMount function somewhere here, and it takes just a callback function, which is basically looking like that. And that function is executed when the component is finished with mounting. And then we can say, hey, let's get the context. And then we can just say canvas get context. And here we have to put in the 2D as an argument. And this context will make that also a global variable so that we can access it from everywhere. And then basically we could say something like this. So let's use the $, which means run this line of code whenever something within this line of code changes. And we want to say, hey, if there is a canvas now and, if there is a context, then we want to run the scale canvas function, and that one exactly takes the canvas, takes the context, takes the width, and takes the height. Right now it's looking like that. So now I'm going to my browser again, and now I'm rerunning this, and we can now see here's our main, and now here's the canvas, and now you can see its width and height is adapted to the screen width. When I changed it, there's also something happening. And well, what is the scale canvas function doing? So it determines the device pixel ratio, which is with a normal screen is just 1. So there's 1 pixel in memory and 1 pixel on your screen. It could be 2, which means there are actually 2 pixels on your screen, but only 1 in memory, which increases the sharpness, the clarity basically of your screen. And we can make use of that. And what we do basically is we take the canvas and set the width to the actual width that we measured times the device pixel ratio. So we make the canvas for a device pixel ratio of 2 as double as large as it is on our screen. And we do the same with the height. And then we use the CSS property width and height. That's what we access with this style property, where we set just the width and the height. So we make for a device pixel ratio of 2, we make a large canvas that we style then a little bit smaller with CSS, so that we get, if we have 1 pixel in memory, so what we are counting with, get 2 pixels in reality on the screen. That's just to account for that. Well, and then we do with the pen CTX, we do a scale operation with device pixel ratio so that we can also draw on the canvas without thinking ever again of this device pixel ratio. So well, this is quite complex stuff compared to what we did in previous videos. I let it as it is here right now. Maybe write me in the comments if you have further questions on that, or if you should do some more examples, then we can do. But I think you'll see in a second how it works. And if it works, if we see our circles again, you can also play a little bit around with the device pixel ratio. Well, okay, so now we got a scaled canvas. We also got the context, so we can draw on it. And now what we do is, let me think and just look a little bit on my little sheet here. Basically what we can do now is we can now create a new array of draw functions, and in this array we want to put all the drawing functions of our tens of thousands of circles later on. And what we're going to do now is I complete this canvas component now very quickly with the template I also provide you in my teaching repository. The link is below, and I explain you what's happening there. So this is the line we've also written. This is also the onMount function we've also done, and here we have all the scaling stuff. So what I basically added is this weird set context stuff. And this is something which comes from Svelte, and which is a concept that you have, I think, in each of the front-end frameworks that are out there. It's a way to pass information down to children. And if you want to pass information from a parent component to a child component, you have different possibilities. We already seen one, which is the properties with the export let, remember? And the second one is the context. When you do not really know who your children are, you can just set a context. So parent can say, hey, this is a context variable, and if you are a child, you can just take it and work with it. So with this set context that we basically here imported from Svelte, we use a context name. So this is just a variable that I set to canvas or whatever you like, just a string identifier. And then we set this object here as the context. And this object contains 3 different functions that I define here. There's a register function, which looks like that. It takes a function as the argument. There is a deregister function, which also takes a function as an argument. And there's an invalidate function. All right. So the register function that can then be invoked from the children takes our draw functions array, just an empty array now, and pushes the function that comes from a child into this array. The deregister function is the opposite. It splices out a draw function from a child from our draw functions array. And now the most interesting stuff is this invalidate function. If I run the invalidate function, it asks, hey, there is a variable pending invalidation. If that one is true, then do nothing. Then, if not, set the pending invalidation to true so that my canvas component knows, okay, there's something going on now, don't do anything else. And then we have this line here, which is using this function request animation frame. That's a native JavaScript function, just saying, hey, here is a function, namely the update function. You get that and you have to run it when there's time for it. This update function here, we don't know that basically. That's defined here on top. That's our update function. And the update function firstly asks, is there a context? No, then return, because we need a context. If there is a context, then do a clear rect operation, which means do a blank canvas now. So delete everything which is on the canvas. And after that, you go through the draw functions, take out every functions, ffn, store the context. So just ignore that for now. Then run the function with our context, with our drawing pen, and then restore the context. So basically here we run through all the functions that we got delivered from all the children, that will be the circles later on, and then they are drawn, and that's it. And then afterwards pending invalidation is set to false, and that's it. So with that, whenever we run this invalidate function here, we run through all the update functions here. Well, so we don't have them now. Let's see what's going on there. If we can go back to the mode, yeah, there is our canvas. And at the moment there are all these SVG circles here updating and stuff like that. But we don't need SVG anymore. So we go now to the circle.svelte. And well, we don't need the SVG here, we don't need the style here, so let's simply get rid of that. Because now these circle, if I go to the app.svelte, you see that they are now inside of our canvas svelte component. And that's possible, let me switch to canvas.svelte, because we also have added here this slot element. That means, hey, this canvas.svelte component can take children. And that's what we do basically here. We move in all the circles now with the each loop, right? All right, now then we go to the circle and we say, well, now we have to draw. Basically, we have to define a function which is basically saying the Canvas API how to draw a circle. And let's call that just function draw. And let's say this draw function needs the context as an argument. And then we could say, well, first take the pen and translate it to an XY position. So that just means, hey, take the X and Y coordinate that we get from outside and move the pen there. Then we could say, okay, let's set a fill style. So you remember we have to set that imperatively here, ctx.fillStyle objects, right? And we set that to fill because that's like the variable we get here from outside also as a property. And then we say, okay, then let's draw a circle, and with that we do ctx.beginPath. So with that we start actually drawing now. And you see that I have to look it up all the time because this is really the Canvas API. Has so many different methods. Now we have to draw now a circle. We have to basically draw an arc, and this arc has a center of 0, 0 because we already translated to the right position. And then we say, okay, it has the radius 0, and then we have to use this flag 0, and then we have to say this arc should be a full circle, which is 2 times math.pi. And then we have another flag, not going into details here. You can look it up if you search for context.arc. What all this means, it has to do with the direction, in which direction you draw the circle and where you have cutting edges and whatever. And then we say, okay, now we draw that, and then we want to fill it with ctx.fill, and this should draw us a circle. Well, if you remember correctly, we had some opacity on the circle. So here in the beginning, we could also say ctx.global_alpha is set to 0.8. So that means we have an opacity of 0.8 basically. So that's the draw function. It's defined now on our child, the circle. Question is now, how does the canvas know how to draw this now? And where do we get the context from? That's actually a problem. So what we have to basically do is we have to now access the context of our parent, of our canvas, because in the context we have this register, deregister, and invalidate function that we could use now to actually send this draw function to the parent. And we do that like that. We have to import a nice little function which is getContext from Svelte. And now what we can do is when this component is loading, we could just say, well, we could basically define a context variable and run getContext. And now here we have to pass in the name of the context. And you remember we did here the set context with context name, and actually this context name was here a property which was set to just canvas. So I take that also for my circle and put in the context name here. And within the context we have these 3 functions, so we could also just say, hey, let's get this register, deregister, and invalidate function with the destructuring operator directly out of that object, so that we can work with these 3 functions directly. And now let's also use onMount. And we say, well, when this children is mounted, then we run this function, and then we could say, well, if there's a new circle now, we could just say, hey, let's use the register function and let's send this draw function here through the register function. And now we know what's happening. This register function is invoked with this draw function. That means in the canvas now, the register function is invoked, and fn is now my draw function of this single child, so drawing function for one circle. And this drawing function is pushed into the draw functions array. Similarly, when the circle is basically destroyed, so we could just say here on destroy, we could say on destroy. So when this circle does not exist anymore, the same pattern with the onMount. We could just say, hey, then deregister this draw function. Thank you very much. Then it's gone. So if this circle is not there anymore, then also the draw function is deleted from the draw functions array of my parent here. Well, that's very nice. And now what we could also do when we do the onMount, just to be sure, let's run the invalidate function just once. Invalidate, like that. And that means, hey, invoke now the draw functions. If there is a new circle, just draw it, because you remember the invalidate function, and now you see, oh, there's already circles coming, very nice. The invalidate function is calling this request animation frame with the update function. The update function then goes through all the draw functions and draws the functions, or invokes the function, the draw function, with the actual context. So here the context is coming in, going through there, running through this, and that's why we see here just these circles. Actually, it's just drawing once. There's nothing happening because we're just running invalidate once when the draw function is when the circle component is mounted. And that's it. So now X, Y, R are changing, but we don't see it actually. So yeah, because we're not running invalidate again and again. And that's now pretty nice. What we have to do basically is there is also something which is called an after update function. And the after update function, same pattern as onMount and onDestroy. This one here, after update function, here we could also just say, hey, run invalidate. And actually this is a lot of brackets. What we could also just do is this, which means, hey, after an update, run this invalidate function. That's basically it. And now if I store that, let's see what's happening. Yes, exactly. Now every 2 seconds we get new circle positions, which is quite nice. Wow, yeah, cool. Let's make that a little bit larger so that we see a little bit more. Yeah. Now every 2 seconds we get new circles. Very nice. So let's reload that because there was a little glitch. So now it should work. Well, that's basically it. The thing is now we get a little problem here as there is no transition. The problem is we couldn't just use here now style, CSS, blah, 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 because these circles here, as you can see here, they appear here as comments. They are not real HTML elements anymore. They are just drawn with JavaScript on the canvas. And that's a little bit of a problem because now we cannot style them anymore with CSS. That means we can't use CSS transition and stuff like that. So we have to calculate our transition on our own. And now you say, oh my God, we need another library or whatever. But no, Svelte basically comes with also the transition batteries included. So what we can do now is basically we could import a cool function which is called tweened from svelte/motion. And what we could do here is we create now a new variable tweened x, and we invoke that here like that. And it has an initial value of undefined, and we do also a tweened y, also with an undefined, and we also can tween the radius, tweened radius, like that. All right. Yeah, basically that's pretty cool. Now we have all these tweens here. What you could do now is we could also say, hey, when you tween, then do this for a certain duration or whatever. And for that we can define a tween params object, and we could say, well, the duration should be 1000 milliseconds. Let's do it like that, and we can pass in this tween params object here in all these tweens stores. So this what we get here, these tx, ty, tr, these are in fact Svelte stores. You do not have to know what stores are, that's maybe for another episode. That just means this is a reactive value. And what we could do here is we could say, well, with the $, we could say, well, tx, we can set the value of tx with x, which means whenever x is changing, then we set a new tx value, and we do the same for ty, and we do the same for tr set r. And now we have to use like these values, and as they are tweened values, if I set them to a new value, there will be an automatic transition between the old and the new value, and that's the cool thing we could use. We just have to use now tx and ty here, but we need the value of these actually, and we can access the value with the $, here. And we do the same for the radius, which is then $tr, and now I store that, and now you can see that we get the transition working actually, which is quite nice. So yeah, that's quite cool. So now we have the transition working, and we can see, well, there's just this canvas, and the cool thing is we could write declarative code. So we have our canvas here, and well, we see that each circle goes there as a child, and we could still use this each loop and stuff like that. We have this canvas component, and it's quite nice. So you could use this canvas component for whatever you need. When you build something with canvas, just go there and just copy that, use it, or put it in your starter project. I'm also thinking about putting this in the D3 Svelte D3 starter GitHub. And then within your circles, you have to get like these contexts and stuff like that. Yeah, that's basically it, how it works. So we could also delete like this SVG background stuff. Don't need that anymore. White background is fine for me. And maybe just one little addition. Of course, when you do these tweenings here, there are more possibilities to customize these tween. For example, you could also add easing, for example, a cubic out function, which is always looking very nicely, and we just have to import that cubic out from svelte/easing, and now the whole animation has little transform on this linear transition, which is now a cubic out easing. Well, that's basically it. Thanks very much for watching. See the project link below in the description, where you can find all the code we did now today. And you can also find the Svelte D3 starter project on GitHub. There's also a link in the description where you can start off with your own Svelte D3 data visualization coding. Thank you very much for today, and see you soon. Bye.